Thanks
Thank
everyone.
you.
So the first half, so this today's session, Anna and I will be giving an overview of something we've been working on for the past few months regarding sharing phenotype definitions. This is part of a larger initiative to ensure research is transparent and reproducible in accordance with the Centre's publication and dissemination policy, as Tom just mentioned. I will take over the first half, introducing the HDR UK Phenotype Library and also providing a live demo on how to manually upload a phenotype definition to the phenotype library using the creation interface. And then in the second part, Anna will then talk about the code that she's developed to automate the process of uploading phenotype definitions to the library using an API approach. So just referring back to the Centre's policy, so just highlighting the main points about the policy, so open access, rapid sharing, acknowledgement, transparency and reproducibility. A main point of this presentation is ensuring that researchers share detailed phenotype definitions and code either to the phenotype library and or GitHub repositories. So just a brief overview of the HDR UK Phenotype Library. So this is a web-based platform which is designed to help researchers and clinicians create, document and share phenotypes. It supports a wide range of research needs and also makes it easier to find, reuse and share well-documented phenotypes. Again, a key goal of this resource is to improve reproducibility and transparency in health data research by providing a central curated resource. So some of the key features of the phenotype library is its rich metadata model. So each phenotype entry includes a unique identifier, accession ID, the data set used, the coding terminology used for the phenotype definition, along with detailed definitions and implementation guidance. It also has functionalities to integrate with PhenoFlow for workflow-based implementations. Specifically, within the consortium, we advise researchers to use the VHF Data Science Centre schema, which has enhanced metadata and thus allows for the phenotype to be described in greater detail. Additionally, we're always continuously working with the phenotype library team to improve functionality. So when uploading phenotypes to the phenotype library using the creation interface, these are some of the main steps to go through. So you'd first request a user account via the contact us page on the website. And then once you have access, you can upload new phenotypes or edit existing ones. The upload process is fairly straightforward. You enter the required metadata fields and upload your code list, typically as a CSV file. There's also version control, so any updates or changes are tracked, with each change providing a new version ID. The phenotype entry, once you upload a phenotype entry to the library, this generates an accession ID, which should be referenced in publications whenever you've used that phenotype definition. Just a note about the Codelist format when uploading Codelists as CSV files in the library. It's important to ensure the correct formatting to prevent errors. So you should have the CSV file with 2 columns. So one column specifying the code and the second column specifying the description. And the ordering of this is important as well. I'm now going to do a walkthrough of uploading a medication phenotype. These are the steps that I'll follow. So I'm already logged in, and then I'll fill in the required metadata, upload a code list, and submit for publishing as well. I'll just stop sharing this PowerPoint so I can share my screen of the phenotype library. Thank you. I hope this screen is sharing for the creation interface of the phenotype library. Thanks. So once I've logged in, I'll navigate to the Create a Phenotype section of the web interface and select the VHF Data Science Centre Phenotype section for uploading centre-related projects, consortium projects, for example. So in this example, I'll be adding a medication phenotype from one of the existing consortium projects. So this phenotype entry page has a number of fields, metadata fields. Some of them are optional, a majority of them are optional, and then there are a few mandatory fields, which I'll be filling in the mandatory fields for this example. So for the phenotype name, we'll use this naming convention. So the project number, which is CCU 014_03, and then the medication name, so lamotrigine. And then I then fill in the author list, so just a text with all the author names involved in the publication, the phenotype type, which is a drug, and then the biological sex that this phenotype is applicable to, as these fields are all mandatory. There is also optional fields for inputting the data source. You can simply search for whichever data source is relevant for your phenotype definition. And the collections field for the consortium projects, we would enter in VHF Data Science Center and also the phenotype library options. These definition field is an optional field, but typically you could enter any further detail, which provides further detail on how to accurately apply your phenotype definition. So any users that come across this phenotype definition and are wanting to reuse this could apply this accurately. So you could put the coding the data sources used and the coding terminologies and any other inclusion criteria as well. And a field for implementation where you could link to PhenoFlow ID. I'll leave these all empty just for the sake of timekeeping. So this is the next important field, which is adding in the code list. So I will import the code list as a CSV file, and you enter them as a concept. So each concept is represents the coding terminology used. So I'll add the BNF codes for the lamotrigine. I'll just name this the lamotrigine. And then importing the CSV file, I'll go to inclusion roles and select add role, and then import from file. I have this helpfully ready to go. So I'll select the CSV file and check it's been uploaded correctly. So the CSV file will be formatted as the code in the first column and the description in the second column. So it's important to have this order already prepared in your CSV file. And you can just scroll through this section here to ensure everything's been uploaded as you wish. I'll select confirm to save that code list here, and then this is how the concept will be defined within the clinical code list. I can then scroll down to input the publication and the authors and the publisher. So I'll just copy and paste that from my text. And then I also input the DOI in the next section. I'll select primary publication because this is the phenotype defined by the authors in this publication. And that's the final section for that, is just permission. So I'll select the VHF Data Science Center as the organization and create phenotype. So after this, it's important to, so there's multiple options after this. If you're required to edit anything, you can just select the edit option. Otherwise, if you're happy with all changes, you can select request publication. This will go to be reviewed and then published. And then once it's published, it will be available to all members of the public and not just logged in users. So anyone that comes across the phenotype library will be able to view this. I can click request publication and then that should go through. Yes, you just double check and I click publish. Seems to be taking a while. Okay, so it's pending approval, and then you typically get an email from Concept Library when that's been approved and finally published. I'll just also go through just the general search functionality of the Phenotype Library, just to reiterate that this phenotype library resource allows for reusing of phenotypes. So you can scroll through the list of phenotype entries. You can also filter by collections, and you can also use the actual search string. So if I wanted to search for phenotypes with heart failure, I could do so, and then it would return with those entries for heart failure. And if you're wanting to use these in your publication or research, you could use the accession ID and you'd reference that in your publication. So using this citation example, you could reference this in your publication as well. I think that's everything I wanted to demo for the this phenotype entry. Thank you very much for listening, and I will now stop sharing and pass to Anna for the second part of the presentation.
Thanks, Jadene. Okay, I'm just going to share my screen now. Hopefully that's coming through okay. I am going to be dotting about between slides and code and stuff, so if you can't see stuff, just shout and I'll fix it. But yeah, so Jadene has covered how to upload phenotypes using the Phenotype Library interface, which is a great option if you don't have that many phenotypes to upload. But if your project does have multiple phenotypes, you might want to consider using the Phenotype Library API. So just in case you aren't familiar with APIs, they're basically just a way for different software applications to communicate with each other. And the Phenotype Library have produced instructions and example files to use with the API, which we can link to later. So you can familiarize yourself with the process before you actually upload your own phenotypes. But basically, to use the API, the metadata for each phenotype needs compiled into individual YAML files. Now, doing this manually would take about as long as using the interface. So we've created some scripts to speed up and automate the process to cut down the time it will take, which hopefully will be useful, particularly for projects that do have multiple phenotypes to upload. So the scripts cover formatting Codelists, creating YAML files, and batch uploading phenotypes. I'm just going to briefly cover what each script does, and I'll show you them in action. So firstly, we have produced a script to help configure Codelists into the correct format for upload to the Phenotype Library. So Jadene obviously covered the format that the code lists need to be in. And I know people have different methods for how they format their code lists, but essentially this script takes a master code list that might include various different phenotypes and various different coding terminologies. And it splits them into separate CSV files based on the unique combination of the name of the phenotype and the code type. And for each combination, it creates a CSV file containing only rows for that group and then saves them into an output folder ready to be uploaded to the Phenotype Library. So I'll just quickly switch to the code itself. So yeah, the script reads in a CSV file containing all your codes. I've just used an example file here, but obviously you can change it to your file. And it expects two columns, so the phenotype name and the terminology, and it then cleans up the grouping columns and creates an output folder called phenotype CSVs, where all the CSV files will be saved. And it then groups the data by phenotype, name, and terminology and processes each group one by one. So at the end, we get one CSV file per phenotype terminology combination, and these are stored in the output folder ready to be uploaded. So if I just run that, and then I can switch to show you, so it will kind of track through showing you how many rows each file has. Sorry, I've managed to choose a very large example, so it's going to take ages to run. I'll actually just stop it. And then if we go to the output folder, you can see all the CSV files are listed there. So with the phenotype, atrial fibrillation, and the terminology SNOMED or ICD-10. So I'll just switch back to my slides. Yeah, so next, as I mentioned earlier, to use the API, we need the metadata for each phenotype compiled into individual YAML files. Now, the Phenotype Library have put together an example YAML file to show you how they should look. Again, we'll link to all of these resources later. So you can see here each field that needs populated is very similar to what you see on the interface. And they've also provided an annotated YAML file which explains what's required for each field. It also provides some reference data and notes whether each field is optional or mandatory. So these are really useful files to have before you start creating your own. Now, in order to speed up the process of creating YAML files, we've created a script that extracts phenotype metadata stored in a master Excel file into individual formatted YAML files for each phenotype. And again, it saves these to an output folder ready to be uploaded to the phenotype library. So I'll just quickly come out of my slides again. So I'm just going to show you an example metadata file, because this is where like a little bit of work is needed in order to compile it. So basically each phenotype is listed, so each row is a phenotype. So you can see phenotype 1, phenotype 2, phenotype 3, etc. And each column is one of the fields in the YAML file. So obviously not all of them are mandatory, so you can just fill in the ones that you have data for. And then in this last column, or second last column here, the concept information column, this is like the add concept section on the website. So it details the coding system, the reference values are in the example file, and the file path to where your Codelist sits. So obviously it does take a bit of work to pull a file like this together, but probably for the vast majority of your phenotypes, the columns are all going to be the same. So you can just pull through the data for each phenotype. And then it's really only the concept information column that you might have to edit just to specify the file path, which hopefully shouldn't take too long. And I'll just show you the script quickly. So first it loads the phenotype metadata file. Obviously in this case it's the example file, but you can edit it to point at your own file. And then similarly to the Codelist script, it creates an output folder called phenotype YAMLs where all the YAML files will be saved. It then defines some helper functions, and then it starts to loop through each row of the Excel file, extracting what's needed for the YAML file. So at the end, we've got a YAML file for each phenotype that are ready to be uploaded to the phenotype library. So again, I'll just show you in action. It runs very quickly. If we go to phenotype YAMLs, you can see all the individual YAML files here. And if I just open one up, you can see it's populated with all that information that was in the Excel spreadsheet. Okay, I'll just go back to my slides again. So lastly, so you've got your Codelist formatted, you've got your YAML files ready to go, and you can just upload them individually using the API. And again, the Phenotype Library have provided an example script for doing this. And this script is really useful because it allows you to upload phenotypes to a demo site, so you can preview how the phenotype will actually look before you go ahead and then upload it to the main production site. But again, if you've got a lot of phenotypes to upload, and doing each YAML file individually will be fairly time consuming. So we've created a script that loops through all the YAML files and uploads them all in one batch. So again, I'll just switch to R and show you. So basically it just loads the required helper tools and packages that are needed to connect to the phenotype library. You then need to specify whether you want to upload to the production site or to the demo site by toggling this function here. It then logs into a phenotype library account. So in this script, it's set to a generic BHF DSC login that you're welcome to use to trial your own uploads. And then you can change the login details to your own once you're ready to upload to the production site. Now, instead of uploading just one YAML file, the script will look in the phenotype YAMLs folder that we created earlier, and it grabs all the YAML files from there and it loops through each one and creates a copy in an output folder and then starts uploading them to the phenotype library. So I'll just run it. If all is well and good, you should get a success message with some details like the phenotype ID and the version ID. So you've got that information straight away. If something goes wrong, like a formatting error in one of the YAML files or something, it'll log the error so you can see what's happened, but then it will move on to the next file. So if one file fails, it won't stop everything. I'll just quickly move to the demo site itself. So this is what the demo site looks like. You're obviously logged in as the generic BHF DSC user, and hopefully, you can see the phenotypes have already uploaded here. And if I just click into one, it looks very similar to what Jadene showed earlier. And you can just view it, make sure it all looks okay, make sure the code lists look all right. And then if you're happy, that's when you can switch to the production site and send them there and have a look there and then request their publication. So this should make it easy to batch upload multiple phenotypes at once, which hopefully will be useful for projects that do have a large number of phenotypes, as uploading these manually is pretty time consuming, and a lot of the phenotype metadata will be the same. So just to finish off, I know that's been a really quick fire tour of everything, and I kind of bombarded you with information and files and scripts in a really short time frame, and probably given you motion sickness from dotting about between screens. So I apologise for that. We can send the slides, which have got some useful resources for you to have a look at. And also all of the files, all of the scripts that you need to use these resources are on our documentation site here. So please just use that link, have a look at the resources, try and get started. And if you're having any issues or you've got any questions, just get in touch with us and we'll be able to help you out. But yeah, thanks very much for listening. And if you do have any questions just now, I'm more than happy to answer them.